So welcome to a video short about Cartesian products. Let's get started. I'm going to pin my notes page. So here's our definition for a Cartesian product. It's a cross product. Given sets A and B, the Cartesian product of A times B, and it's denoted by A cross B. So we read it A cross B. It's also called a cross product. Is defined as follows. A cross B is a set, so we'll open set brackets. Now the elements look like ordered pairs where we have a first coordinate and a second coordinate, like when you would plot points in the XY plane, except here instead of X coming from the reals and Y coming from the reals, we have the first coordinate coming from set A and the second coordinate coming from set B. The XY plane is R cross R, by the way. So it's a soft bracket, little a, comma, little b, close your soft bracket. So that's an ordered pair, such that, right? Our vertical line means such that. This is descriptive notation of a set, or set builder notation. Little a is an element of set big A, and little b is an element of set big B. So little a is called the first coordinate, and little b is called the second coordinate. And this entire object, these elements, are ordered pairs. So this is an ordered pair. Okay, and the easiest way to understand these is just to look at some examples. So let's look at a couple of examples. Let's suppose that we have a set A that's got the elements 1 and 2 in it. And let's suppose that set B has elements little x and little y in it. Let's find A cross B. So one of the nice things that we can do is we can count how many elements or ordered pairs we should expect to get before we even start building A cross B. Well, let's just look. A has 2 elements, 1 and 2. So we have 2 choices for this first coordinate, little a. B has 2 elements, x and y. So we have 2 choices for the second coordinate, C. So we have 2 choices for the first coordinate times 2 choices for the second coordinate for a grand total of 4 ordered pairs is what we should be getting. So here's our solution. I'm going to do this in a methodical way. Let's open our set brackets. It is a set. So A cross B is a set. The first element, well, I'll open soft parentheses for the ordered pair, and we'll just take this first element of A. That's 1. That's a first coordinate. It's one of the possible first coordinates. And we're going to mix and match it with both x and y. We'll do them one at a time. So second coordinate could be x. So 1 comma x. That's the first element that we've listed. Now remember, the order that we write elements of any set is irrelevant, but inside an ordered pair, the order of the coordinates does matter. The first coordinate has to come from the first set, and the second coordinate has to come from the second set. All right, so just to continue in this methodical way, I can use little 1 as the first coordinate and x as this, excuse me, not x, we already did that one, y as the second coordinate. So that's another ordered pair in A cross B. What's the next one? Well, we've exhausted all the possible ways to use 1. We've used it with x and used it with y, right? So let's move on to 2. 2 comma x is one of the elements, and 2 comma y is the last element. So 4 ordered pairs in a set A cross B where A and B both had 2 elements. Let's look at another example, just up the ante a little bit. Let's suppose A has 1, 2, and 3 in it, and B has X, Y, and Z in it. We're going to find A cross B. And now we might say, well, how many elements are there going to be? How many ordered pairs? 3 choices for the first coordinate times 3 choices for the second coordinate. 9 elements, 9 ordered pairs. You may be wondering now, do A and B always have to have the same number of elements? Nope. But here they happen to. So 1x, 1y, 1z. Okay, so we've exhausted 1 as a first coordinate. 2x, 2y, 2z, 3x, 3y, 3z, and that's it. Close up your set brackets. It's okay to put the elements of a set on 2 lines, but don't ever split up an ordered pair between 2 lines. All the symbols in an ordered pair need to be consecutive on the same line. Like you would never write the 2, comma, and then the z over here and close it up. No. The ordered pair needs to all be together. So again, we don't have to have the same number of elements in A and B. In fact, let's let C be the set containing 4 and 5, and let's let D be the set containing 4, 6, and 8. It's okay for these elements to be in both sets. We could make C a subset of D even. Here it's not, of course, because 5 is in C and it's not in D, but we could do. Anyhow, let's find C cross D. Well, how many elements will we have? We'll have 2 choices for the first coordinate times 3 choices for the second coordinate. So that's right, 6 ordered pairs in C cross D. 4, 4 is one of the elements because we can take 4 from C for the first coordinate and cross it with 4 from D for the second coordinate. 4, 6, 4, 8, 5, 4, 5, 6, 5, 8. I think you got the drift. Now here's a question. Is C cross D going to be the same set as D cross C? Well, let's just think about our answer. 4, 4 would be in D cross C because 4 is an element of D and 4 is an element of C. But 4, 6 is not going to be in D cross C because 4, while it's an element of D, 6 can't be a second coordinate because it's not in C. So the answer is no. Let's go ahead and find D cross C just to show ourselves it's not the same set as C cross D. 4 can mix and match with 4. 4, 5. You see, that's an element in D cross C, but 4, 5 is not an element of C cross D. 5, 4 is not the same element as 4, 5. All right, so we've exhausted the 4 from D as the first coordinate. Now 6 can mix and match with 4 and with 5. And finally 8, 4, and 8, 5. So in general, C cross D will not equal D cross C. Now there is one time when C cross D would equal D cross C, and that's if C and D are the same set. And we do cross the same set with itself. For example, when we think about the XY plane, we have crossed the reals, that's our x-axis, our first coordinate's our x-coordinate, crossed with the reals, the y-axis, the up-down coordinate is also a real number. So that's one time when we use the same set for both A and B or C and D, but it doesn't have to be that way. All right, so that's our video short on Cartesian products. You can up the ante if you want. You could have an A and a B and a C. And you could have ordered triples instead of ordered pairs. You could build something called A cross B cross C, where first coordinates come from A, second coordinates come from B, third coordinates come from C. So if you did that, how many ordered triples would be in A cross B cross C? for the A and B in example 2, and the set C in example 3. I'll just leave that question for you. Thanks for watching. Have a good one.